Good morning, good afternoon, good evening, everybody, wherever you are. Welcome to the INSEAD Global AI Leader Series, event number 6. I'm Theos Evgeniou, professor at INSEAD, and I'm hosting this series for you. It's been a pleasure to be here for the past 5 events. Today, we have another exceptional speaker, one of my favorite faculty in computer science this year, I must say, Percy Liang, who's a professor of computer science at Stanford University and also director at Stanford Center for Research on Foundation Models. And we'll discuss with Percy about generative AI and foundation models. He's an excellent person to talk with about these topics. We'll cover issues around research questions today, open questions today, questions around evaluation of models, questions about how we got here, open source also discussions, which is a topic that comes throughout the whole series, as some of you know. Percy, thank you for joining us.
Thank you, Theos, for having me. Pleasure to be here.
Let's go to the next slide. I'll do a quick introduction to the webinar series. Again, this is the previous events, which are all recorded. You can all find them on the website of the series. We have the last event in July, where we'll discuss with INSEAD alumni and MBAs on what were some insights from the whole series itself. Next slide, please. Yes. As always, the webinar etiquette, you probably know it by now. You are muted with your videos off. Chat is closed. Please enter questions in the Q&A and vote them up or down, so we can select the ones which are the most interest. As always, the webinar is recorded, and if you have any technical issues, hopefully you don't, please email digital@insead.edu. Next slide. And as I mentioned, we'll discuss today, the focus will be specifically on foundation models and generative AI. Some of you have been hearing about this term foundation model for some time. We'll demystify them, and we'll also discuss about all sorts of exciting research going on these days in the labs that probably will be hitting us, who knows when, in the near future probably, or maybe some of it in the further down future. And again, a pleasure to have here Percy with us. Thank you very much. Next slide, or maybe no more slide. Okay, great. So Percy, thanks for taking the time for this. Let me just start with just setting the stage. You are the director of the Stanford Center for Research on Foundation Models. So first of all, what are foundation models? What's this term coming from? What does it mean? What is a foundation model? Just for the audience to understand.
Yes, thanks, Theo. This is a great place to start. In 2021, we founded the Center for Research on Foundation Models, and we defined foundation models as models which were trained on broad data, usually at immense internet scale, that could be deployed to a wide range of downstream tasks. So now, of course, 2021 wasn't any particular day. There was a whole line of work building up to this. But for me, at least, 2020 or 2021 really felt like a transition, a phase transition, if you will, of how AI was going to evolve. And in 2022, we see ChatGPT, and then the rest is history. But I feel like 2020, 2021 was a really big inflection point. So the reason we coined foundation model is because of what we felt to be a paradigm shift, right? The normal way you build AI systems before in the 2010s is you collect a bunch of data, you define a particular task, usually narrow, like summarization or image classification, and you build a model for that particular task. And then you go to a new task, and you have a different team that's building a different model. So foundation models changes that paradigm. The idea that you can have a one-time cost, invest a huge amount of capital, and build a single model, and then that model is a general purpose and then can be easily adapted to a wide range of downstream tasks, where the adaptation might be as simple as prompting the language model. That really changes the game and how we even think of what an AI system is. So that's why we introduced the term. I would say that foundation models is a broad umbrella term that includes many things that you are probably familiar with, such as language models, such as Claude or GPT-4 or Llama, but also includes other models which are not language models, like text-to-image models, like DALL-E or Stable Diffusion. It also includes DNA models, like EVO or ESM-fold. So broadly speaking, I think one thing I want to emphasize is that foundation models is a much deeper and broader phenomenon than just what people typically are familiar with if they see ChatGPT.
So this is really a paradigm shift in some ways. We don't train our narrow use models necessarily. We use something which is multitask in a sense, multi-purpose. You mentioned the DNA one, which is something probably not everybody is familiar with, which probably mostly works for biological data or all sorts of different tasks of biological data, I assume. Right? So you have a broad, again, list. Okay.
Yeah. So it's really interesting how every field you see papers now coming out and talking about foundation models for X, for earth science, or for astronomy, or foundation models for neuroscience. And it's really a sweeping paradigm shift. I mean, I think it's still early. It's very early. People haven't really established this as the way to do this, but people are looking at examples in language and vision where it has been successful in trying to figure out how you can build foundation models for many other fields and sectors. Because once you are able to get something like that in place, it really changes the game.
So we kind of expect to have not just the large language models we're all familiar with as foundation models for some tasks, but also kind of problem-specific or area-specific or even sector-specific models which are trained for a wide range of use cases over there in some ways, right? So there's no universal machine in some sense, right? Would you say that is there any chance we end up with one foundation model kind of architecture, or probably that's too much to ask for?
So it's a good question. I mean, I think certainly in the public sector where you see the GPT-4s and the Claude, there is sort of this ambition of training a single model that can do everything. But I think in many areas, if you look at the many cases where there is actually a large amount of bespoke data, like sensor data, or you have retail where you have tons of data on customer or consumer behavior. There are cases where there is abundant data to create something that is superhuman in terms of its predictive ability. And on top of that, I think there will be many, as we'll hopefully get to later, models are not, it's not like an operating system. You just need one operating system, you're fine. Models embody a lot of values and decisions about what is right and what is wrong. And you could imagine different countries wanting different foundation models.
Very important. We'll come back to this later, because you are doing a lot of work on evaluation and values and of models, which is fascinating. Let me step back for a second and see how we got here. It's a question we discussed in the very first webinar with Tommy Poggio and Amnon Sasua, where I asked them what they thought was the most surprising kind of, the biggest surprise they've seen in the developments of AI. They both said that big data kind of got us so far, something they didn't expect. They were kind of hoping maybe some math or some model would do so. You've been in this space for a couple of decades. What was the most surprising, the biggest surprise to you from what you've seen? You talk about the inflection point, but maybe there's more.
Yeah, so the biggest thing to me is not what the model can do, but the difference between how it was trained and what it could do. So I think of this as, I use the word emergence sometimes to talk about that. And so I think this is an important point, and to break it down a little bit more. So these language models, let's just think about language models as GPT-4. They are trained on a huge amount of internet text, and they're trained given some text, predict the next word or the next token, right? And they do this over and over again. So it seems like a very rote and mundane task, predicting the next token. It doesn't look like anything like dialogue or question answering or summarization. And at test time, which is once you train one of these models and you adapt it, now you ask these models to solve all sorts of tasks. You can solve math problems, you can solve coding problems on all these. So the difference between how it was trained and how it's used is different, right? And I think throughout the history of AI, if you think about narrow AI, it's always you train a model to do something. You train a model to play Go, and that was big data too. Or you train the model to recognize images and that's a massive amount of data, or recommender system. It's always the training task, at least, is the same as the how you're going to use it at test time. So you have these models that are very good and specialized at what they do. So now the paradigm shift is that you don't have to do that. You train to predict the next token, and somehow this is a sort of a universal task, if you will. Because if you think about it, predicting the next token is not easy, right? Try to guess the next word in a sentence, and actually requires a lot of understanding of what's going on in the context, the syntax and the semantics and the world knowledge. And all of that, the cleverness is that all of that is wrapped up into this one simple universal task. So if you can do that well, now you have a model that is generally capable. And now that becomes much easier to adapt it to a wide range of downstream tasks. So the surprising thing is that that actually works. And this has been talked about for, for some time. Actually, when in 2005 in my master's thesis, my first exposure to AI was building a sort of a language model that was trained on predict the next token, and then it could be used for downstream tasks. But that was much more using different set of techniques. But the idea that if you do this at scale and it works, that is surprising. I think it surprised everyone.
So in a sense, it's surprising that foundation models exist in that sense, right? So you train one thing and you use it for many things, even though it was not trained for that. And it's also interesting, makes me think, I'm not asking this question because I'm not sure there is an answer to this question. Maybe there is another task that somehow proves to be universal beyond prediction of next word that will take us somewhere else. I'm just giving as a mistake.
Well, I think you have to do something different, right? Because if you look at outside language, at vision, or look at a video, it's probably not, and people don't predict the next pixel in the frame, every single frame, because it just doesn't scale. Or if you look at time series data, it's maybe possible in some theoretical limit. If you did this in a giant transformer, it would work as well, but it is just much more inefficient. So I think if you look beyond text is very compressed, right? Every word has already a lot of high-level semantics, but many of the data, let's say from astronomy data, it's like petabytes of data, and you just don't, you can't predict every single thing. Or if you do medical images, they're also very, very big, and I think there's much more innovation for defining this idea of a universal task that's actually efficient to predict, but also captures a wide range of things that people care about.
Fascinating. The universal task. Quickly, before we move to the next theme, and I'll go to the evaluation and values we discussed before. But just before we go there, what got us here? You mentioned 2021 was an inflection point, but lots of things happened before and of course since. And we discussed before about this. You have like a number of kind of things that will make the top 5 of your list, let's say, or top 3 or whatever it is, about innovations that brought us here. We hear about scaling laws. We hear about language as a meta language, universality of transformers. Maybe you can share with us what are some interesting innovations in your mind that happened that got us here, and explain a couple of concepts for the audience.
Yeah. So just to clarify, for me in 2020, the OpenAI release of GPT-3, that I think was an inflection point. May 2020. I still remember it was middle of the pandemic. I remember opening that paper and it's in my backyard. 2021 was when we founded the center. That was a reaction to, oh my God, we need to do something about this. But I think the ideas here, it's a really good question, because I think there's among some people the sense of like, well, it's nothing new, it's just scale. But actually, I think that's a very unfair characterization. And perhaps one of the things that OpenAI really did well and got right is this idea of scaling laws, which they, among others, pioneered. I mean, they weren't the first to do it, but they were really the ones that embraced it wholeheartedly. And I'll explain what this means. So you think about input and output. So what do you put into the model? You put in compute and data, and you get out a model, and you can measure how good is that model on some loss. Right. And so imagine you have, $100 million and you want to figure out whether you should invest this amount of money in GPUs and data to get a good model. that's a big investment, and you don't know, right? And so the idea of scaling laws is that if you train a smaller model and a sequence of smaller models, maybe at $10 million, $1 million, even smaller. I'm using dollars as a surrogate for amount of flops and compute, because the number of parameters isn't exactly the right thing, as it turns out. Then you can fit a line, and you fit basically, if you think about the marginal decrease in your loss or how good the model is getting as you put in more capital, it actually is fairly predictable. And so this is what I think allows for people to have this confidence and say, yes, we are going to just do it and go forward with it. And there's no reason this needs to happen, right? The idea of laws is actually sort of a misnomer, because it's not like Newton's laws or any sort of laws from physics, but it's just an empirical observation that nature is benevolent. Things are actually nicer than we expect.
So basically, gives you confidence to scale up effectively.
Yeah.
Yes. Before you make the big investment, like you see, we had enough evidence that scale is the way to go in some sense.
Yeah, and I think I want to emphasize that it's the scaling laws isn't about bigger is better, right? That is sort of almost obvious. You put in more, you shouldn't do worse, but how much better and whether you can actually forecast and predict it, and it also helps you with determining how much data and what kind of architecture use. There's a sort of an empirical science, if you want to call it, around how to scale up. It's not just scaling up isn't just adding a zero to your to the scale parameter. There's a lot more moving parts. It's a higher dimensional space, and scaling laws is a set of tools that allows you to actually scale up. So that's one thing. These are more, I guess, observations rather than and more of a mindset rather than techniques, right? Because the idea of neural networks and stochastic gradient descent, all of these have been around for a while, and the idea and of course there are many tweaks, right? And people use different learning rate schedules and slightly different architecture tweaks, but those aren't, I think, the important things. The important thing is the mindset that you bring to this endeavor. So the second thing I think is really maybe interesting is prompting, right? Prompting did not exist 10 years ago, right? The idea that you can talk to a model and have it do things, and you can express a new task in natural language to a model, and it can do something. This is pretty radical. And the GPT-3 paper from 2020 showed this amazing ability to do in-context learning, which is you give a prompt, here are some examples of movie reviews classified as positive and negative. You give some examples of movies, and this is all just a part of instructions. It's not it's just words that you're telling the model, and it processes this and somehow is able to solve the task. So this is another what I call emergent behavior, because it wasn't trained explicitly to do this. And so I think there's something interesting about language is this sort of meta language, right? And language is can be used to describe the task, but it's also the data itself, right? You think about a document, you're trying to classify, that's the data, but language itself can be used to describe the task. So I think there's something deep about language models, which is different from, I think, vision and other modalities here. And maybe
the meta language, the data and the code in some sense, right? And the description in some ways.
Yeah.
So there is a lot to understand there. You mentioned a couple of kind of emergent properties, and which is surprising, and kind of how does this happen, right? So which also to get us to the next theme also takes us to the question, how do we even control these things, right? I mean, if it's all this emergence and all these properties that are coming out, how do we even test? How do we evaluate? You've done a lot of work on evaluation. You've also done a lot of work on transparency reports. Lots of the people in the audience I know have been following your reports on transparency reports of foundation models. Can we talk a little bit about your work on the testing and evaluating models, and also maybe afterwards a bit on the transparency report you're doing?
Yeah, sure. I think this is a good segue. So we talked a lot about how impressive these models are. And I should say, and everyone already knows this, but it's worth saying explicitly, that these models are far from perfect. They make all sorts of dumb mistakes, and they're biased, and they have a lot of flaws. But it's also easy to pick on the flaws and miss out on the opportunities. So I think it's that's why we called our initial report on the opportunities and risks of foundation models. But on the question of evaluation, this is really, really hard. I don't think anyone has a good answers for evaluation. And it's because, if you think about evaluating a narrow system, okay, you're going to evaluate image classifier. It's also hard in some ways, but at least the task is well constrained. You can define a distribution over different types of input images, what you care about, different categories. You can provide distance metrics, and you just focus on evaluating that. So as we discussed, language models are general purpose. So any instructions, any task is fair game, right? So the space of possible things is just, enormous. How do you evaluate general intelligence? We've been trying to evaluate general intelligence for humans for, centuries, millennia probably, and we still don't have a good answer for that. And hopefully in some ways LLMs are easier to evaluate than humans, but because they're reproducible and we can poke at them. Okay, so they're difficult, but that just means that we need to invest and work harder.
You made a very interesting point in passing, which I just want to emphasize, but we'll continue. LLMs or AI may be easier because we can poke them a lot more. There is, as if you do infinite surgeries in a sense, infinite tests, which of course you can do with humans. I'm just opening a parenthesis just because I think it's an interesting observation. Sorry, let's go back on the evaluation part. You're going.
Yeah. And actually, that's an important point, because the way we're doing evaluation, we are very particular about reproducibility, which I'll get to a little bit later. So how do you evaluate language models? So we have been doing some work for a few years. Actually, our work in evaluation and data sets has gone back for almost a decade now. But so we introduced the HELM, which stands for Holistic Evaluation of Language Models, 2 years ago. So this is a framework at this point now for evaluating language models in a holistic manner. And holistic is important here because there's so many different use cases of language models and so many different criteria that you might care about. So what we did in our initial version of HELM is we looked across 40 plus different scenarios, and a scenario is basically a use case. For example, question answering on news articles, or summarization of books or something. And for each of these use cases, we also define a bunch of metrics, how accurate it was, but also how confident or how calibrated a model is, whether it's confidently wrong or if it knows what it doesn't know, how robust it is, whether it's biased, how efficient it is, and so on. So that's the space of the evaluation. We also looked at all the models that we could get our hands on, and we put all the models and everything into a standardized format and just ran all the comprehensive evaluations. So I'm emphasizing this as more of a framework and a mentality that we should be evaluating all the models in a fair way on the same data sets, because before that, a model would come out, people would evaluate on some data sets, and this other model would come out, would evaluate on different data sets, maybe in a different way with different prompts, and nothing was really comparable. So what we're trying to do with HELM primarily is standardization. Okay, so now I think there's a few other things so you can think about HELM as the this engine for standardization, and the evaluations are done, and everything's reproducible. You can go to the Helm website, you can look at all the, not just the numbers, but if you click on a number, you can look at the actual predictions, and you can go, oh my God, the language model did this, which you can't really do otherwise if you're just staring at numbers. But we also are innovating on different approaches to evaluation. So we're still doing the research that gets integrated into Helm. So for example, we've been figuring out ways to do text-to-image models and visual language models, so going into the multimodal space. We've been trying to figure out how to do evaluation of language models on free-form generation. So if a language model generates an essay, how do you evaluate that? And defining, using language models themselves to evaluate them, and so on. So there's a bunch of research projects that we are building on that give us basically the sort of going forward and figuring out what is a frontier of evaluation and bring those things back to standardization.
So you mentioned you can use AI language models to evaluate also language models. So you actually,
yeah,
okay, very interesting. I mean, now, of course, evaluation sometimes has an objective measure. In some tasks, in other tasks, it's very subjective. In some other ways, like especially when with the evaluation goes towards more value-based kind of evaluation about safety. Let's say I'm not saying that's the key metric here. That's very subjective. So now this takes me to a question, a bit different question. You also wrote an article on this, by the way. I mean, you wrote so many articles. I couldn't pick the ones to talk about language models and opinions. I think the title of the article has something along the lines, whose opinions language models reflect. Can you tell us a bit about this? Because it's a fascinating question, and I'm sure it has lots of implications about society also in general, and about research also.
Yeah, so the main point of that paper was the idea that language models are not neutral objects, right? We think of them as technologies, but I want to emphasize that these are not just Google Sheets or Linux or Windows or your iPhone, right? These, where of course there are some values embodied in the design and so on, but more or less they are just containers in some sense. But language models also are not just a container, but also have the contents. So if you ask a language model, who's the best basketball player, or what should I eat for breakfast, or what do you think about certain controversial topics like abortion, they'll probably refuse to answer, but you could probably probe it to reveal some of its preferences. And so because again, going back to the general purpose of nature of these language models, you can ask them anything, right? And so therefore these language models represent culture, and they represent values. And we see that different language models represent different cultures and values. The ones that are trained in China certainly are a bit different than the ones that are trained in Europe versus the US. And even within the US, Claude is a different model than in OpenAI. And so this is something I think needs to be thought about very, very carefully, because imagine a world where in the future, or maybe not even that distant in the future, where the main way that a human being interacts with a computer is through a language model. It's like you have your virtual assistant there. So if the model is mediating all the information that you're getting and projecting its own values on, that is a lot of power and control that whoever is designing the model has. And so I think this is really important to realize that it's not just, oh, you're working with a language model and it's a helpful assistant. Like, what does helpful and harmless assistant even mean? You have to unpack that, and aligning to values. Whose values are we talking about? So I think one natural way to maybe move forward is thinking about the plurality of human values, and how a language model could either represent that itself or have different language models that represent different values.
So
yeah.
technically, how will we go around building this? Is it from through just the kind of feedback we give to the models, and also how far can we push it? There is a question in the Q&A that relates a little bit, which is, can the foundation models be built at a personalized level? Maybe it relates a bit to this personalized or value-based level. How far can we push it? Any thoughts on this?
Yeah, so I think at a technical level, this is doable in the sense that if you have a particular set of values or criteria you care about, we have the technical tools to fine-tune language models to do reinforcement learning for human feedback and implant those values in. The key question is, the incentive structure and sort of almost the politics of how that is going to happen. Because right now you have, companies who hire annotators. Some small set of people write down their values, and then they get enforced. And there's no external, oversight over how that is done. There's no laws governing what can be done there. And so it's basically, if you're in control, you dictate the values. And some, I think OpenAI and Anthropic have made some preliminary gestures on how to think about eliciting values from the community, but this is still very, very nascent. And so you can think about what is a more democratic way. So if you think about the democracy and the allowing people to voice an opinion, how can you use maybe technology itself to actually solicit values from people and have language models that are broadly representative of what people think. And now I think the personalization question is interesting because I think there's two parts here. One is things that I don't mind. Things are just going to be different from people, right? Maybe I prefer my responses to be English. You prefer them to be, in Russian or Chinese or something. Personalization, of course. I prefer bullet points. You prefer long, something, a more humorous output. These things are innocuous. But there are some things which revolve around, the truth, whether climate change is real, or whether we should have certain types of laws in the country, in the respective countries, that you can't have people just living in their own personal bubbles, right? So we have to have personalization and some sort of agreement or discourse, at least, about the things that are controversial.
Yeah, Percy, maybe it's me. I don't know if the audience can see this, but your video is frozen on my side. Maybe you can turn it on and off again. I'm not sure.
Okay, let me try to fix that.
Yeah, sorry for this. Hopefully, sorry. Maybe it was okay. I don't know. It was definitely on my side. This takes us a bit, of course, on the political part, and let me do a quick dive on that and then go back to the technology, because I think, given also your research lab, the technology research questions are very, very interesting. But let's briefly talk a little bit about, you wrote a pretty influential article back in November. From my understanding, it's been pretty influential all the way across the Atlantic, let alone across the US, the whole US, from where you are, of course, right? Which impacted kind of the debate in the EU about the EU AI Act around foundation models. It was an article that was called "Towards Compromise: A Concrete Two-Tier Proposal for Foundation Models in the EU AI Act," where you also talk a bit about open source and also open weights. Can you first of all give us a couple of highlights about what's the main idea, the main proposal there, and also tell us a bit about how that applies? What was the proposal also about the open versus not open kind of models?
Right. Yeah. So there's a lot in here. So maybe let me try to pick out a few nuggets here. So as we all know, regulation of foundation model is under a hot topic and policy, given the increase of capabilities of this technology and its impending wide impact in the world. So now the question is, how to regulate, or if to regulate, or what to regulate. And one of the questions here there is, is this idea of tiering, right? So if you think about, if I train a very small language model for my own class project, of course, it would be ridiculous to have to register this with the the EU, but GPT-5, probably there should be something there, right? So how do you decide which are the models that don't need much attention and which are the models that need scrutiny? And there's three ways. I'll provide a framework to think about this. There's three axes that I think are important to determine whether something should be regulated. First is, well, I'll just say the three are resources, capabilities, and impact. So resources has to do with how much money or flops you're putting in. And this has been the one that has been adopted. So EU has 10 to the 25. We also see 10 to the 26 in the US in terms of flops. So if you have a model that's trained using that many flops, then that means you need to get scrutinized. And the reason for doing that is, again, scaling laws. The more you put in, the more capable the model is. But not a direct connection. It's not necessarily causal, but it's just an empirical observation. And this is something that's easy to measure. Even before training the model, you can kind of register and say, okay, I'm going to do a big run.
Yeah,
so it's easy.
Very easy proxy, right?
Yeah, it's an easy proxy, but in many ways, it's really not ideal, because there could be models that are smaller that have do a lot more harm. There's also could be models that are bigger that don't are harmless. So there's not really getting at the key thing. The second thing is capabilities. So this is based on how capable a model is. So the theory here is that if a model is really, really capable and can be used in agents and do all sorts of things in the world, then we better be careful. If you go and do persuade people or of things and write code really well and make long range plans, then we better scrutinize it.
So
the problem with this,
your evaluation work probably also relates to that a little bit and can help with that.
Yes, I was just going to say, the problem with this is that how do we evaluate capabilities, right? I think the evaluation landscape, although a lot of people are, including us, are working on it, is nascent enough that I don't have something to hand to a policymaker and say, if this score is above a certain threshold, then you need to regulate. So, and a lot of evaluations can be gamed and so on. And if a lot of money is on the line, then they certainly, you have to be very careful about that. So that's not perfect either.
Percy, I hope it's not me. I don't.
Oh, hello.
Yeah, you're good. You're back. Sorry. Somehow probably your internet a bit flaky there. Yeah. Okay.
So for the capabilities, it's good, but we don't know how to measure it yet, and everyone's trying to figure this out. And the third is impact, which is how many people is it affecting. And you could have a very small model, maybe llama models, open models are actually, maybe they impact a lot of people, maybe everyone, and that certainly deserves scrutiny as well. So there's a combination of these things. Right now, it seems like the surrogate of resources seems to be what we've been going with.
Yeah.
The other thing I want to emphasize is that is the issue of liability, right? There are some thinking around, well, we need to make sure that the foundation model developer is liable for things that the model can do, downstream. And while this sounds good in principle, I think it's really important to note that this can basically kill open weight models. An open weight model, just so people are on the same page, is a model like Llama 3 or Mistral that is released into the open, and the weights of the model are made public. And the idea of open weight model is that anyone can download it and can use it for whatever they want. Of course, there's still laws governing usage and what you can do with it, but there's no technical measure to prevent people from doing something. And so I think if you're a foundation model developer of open weight models, then if you are liable for anything someone does, then it basically says you can't release models openly, which I think would be a really bad situation for innovation and for research and things like that. One thing that we have been stressing is the need to have transparency, and we can get it. Maybe this is a good time to talk a little bit about transparency. So I think we all want things to go well with AI. And I think the immediate reaction is like, okay, how can we prevent, the harms and maximize the benefits, and what can we do? But I think the problem is that we don't even know what is happening because there's no transparency. We don't know what data models are trained on and how these models are being used downstream. So we don't even have enough information to even have a framework for regulating these models. And so that's why over the last year we've spent a lot of time just focusing on transparency. And so we came out with the transparency report last year in November, and we just recently updated it last month. And the transparency index evaluates all of the major foundation model developers based on 100 different indicators on whether the model developer for their flagship model was transparent about a particular indicator. And the indicators are pretty expansive. So we have a pretty broad notion of transparency. It includes things like whether people are talking about their data. Usually the answer is no. Whether they have they're transparent about their labor practices, what compute they're using, what kind of methods, or whether they're evaluating the models for their capabilities and risks, what kind of risk mitigation they're doing, how they're disseminating the model, what is the usage policy, if they're clear on that, what are the means for monitoring and feedback, and so on. So if you look at the foundation models, there's an upstream, which is all the things that are needed to build it. There's the model itself, which is we want to be transparent about what the model is and what it does. And then there's the downstream, how is the model used? And so all three domains constitute the foundation model in the transparency index.
There's a lot of, so just a bit of to clarify. So there's a lot of work you are doing on the 100 plus or whatever these indicators that are important for us to understand for every foundation model to have a better understanding of how it works, the transparency report that you mentioned. And this is in addition to the evaluation, the holistic evaluation. So basically, there's a lot of work to be done to understand these complex models in order to make sure we can also kind of manage the risks and improve the capabilities in some ways, both on the transparency side and the evaluation side. So there's a lot of research you are doing at the center. Sorry, I interrupt you on this. Unless you have something to add on this discussion, I'm very curious to spend some time, given also where you are at Stanford, about technical research work you're doing today. Because I think the audience would love to hear also about what's cooking, what's exciting, what's a big thing. Let me just start from one question about, what should we expect to come out of your lab next year? Like what's an exciting research project you want to share with us potentially that you are doing these days?
Yeah, so we've been quite interested in actually two very polar opposite directions, I would say. The first is, given that we have all these capable foundation models, what are the possibilities? What can you do with them? And one of the things that we've been experimenting with is building agents. There's two types of agents. The first is agents that are meant to simulate humans. So we had a paper called Generative Agents came out last year that pointed at an idea that you can actually design a simulation of agents that interact with each other in interesting ways. Each agent is backed by a language model. And you can look at different types of social dynamics where one agent tells another agent something and information propagates. So that is a direction that I think is interesting. And furthermore, how can you actually make these agents more realistic? Can these agents actually, mimic particular individuals like you and me? So this is really fascinating because we're working with social scientists on this project because they're really interested in this as a laboratory for doing social science research. And of course, it comes with a lot of different ethical questions as well once you're thinking about simulating humans. So there's a very, I think, rich area there. The second type of agent is building agents that almost are, I would say, researchers. So we've been doing some work by building agents on top of language models that can solve machine learning engineering tasks. Like you give me a competent data set and you want to do some sort of analysis, it can analyze the data, it can write some code, it can execute the code, look at the results, generate plots, and so on. So think about, I jokingly say, half jokingly, say, can it just replace me? And build an agent that, and that might reveal something deep about, who we are and our what we're doing.
How far are we there now? How far are we in this, I don't know, AI researcher or whatever you want to call this, give it a name? How far are we there? What are some roadblocks you see potentially?
I think, I think we still have some way to go. But I'd be happy if it if it happens earlier. I think the main thing is that the last mile problem. You can get a lot of the way there with basic things. Most of the things we do are fairly mundane, right? If you look at a micro level, it's like, oh, okay. But there's a few key critical junctures where somehow it differentiates the good from the mediocre. Like you make the really pivotal decisions, and I'm not sure the models right now are good enough to really have that acute sense. So in the meantime, I think these could be still good autocompleters. They can help facilitate. But I think one thing I'm excited about is pushing them to go as far as you can. So that's
good copilot today, but not good innovative thinkers where they come up with this kind of idea like the famous move of AlphaGo that nobody came up with. We don't see this necessarily in other tasks somehow. It's a bit interesting to see why not in some ways.
Yeah. I think part of it, is because language models are trained mostly to mimic data that's already there, right? And so it's trained on what not necessarily expert behavior, whereas AlphaGo is trained just to win. And if you optimize to win, then you're kind of come up with other creative things to win. So the other thing I want to talk about, so one body of work is, really exciting, pushing forward, aggressively using the best models that exist. The other line of work I really want to focus on is going deep and in the other direction, trying to really dig in and understand how to build these models. And one of the things that has been frustrating, I think, for me as a researcher, having grown up in the AI field for 2 decades, is that for most of the history of this period of time, we had open research. People published papers, they shared their data, their code, and that is what allowed the research community to thrive. And we wouldn't be here without that culture. And now today, I see that the most capable models are all closed. And here I want to make a very important point is that open weight models are not fully open. So Llama, Mistral, they release the weights, which is really helpful for research, but it's still quite a bit of a step removed from having the code and the data and to fully understand what the model is doing. So we shouldn't call them open source, we should call them open weight. So now one thing I'm excited about is ability to build truly open source models for the academic community. There are a few players here. So the Allen Institute has been having a project. There's another organization called LM360, Hugging Face, and so on. And we at Stanford are also trying to see how far we can go. And already, I think you learn a lot about the importance of data and the ability to just understand every piece of the stack, I think is really important for building rigorous scientific foundations.
It's very interesting. The importance of data, you point out that first, which must be a super complicated task. Also, how to create new data. I'm wondering whether you think lots of the innovation now will come from the data side, from the architecture side. Would there be potentially new architecture beyond transformers? What's your take on this, on the next steps?
Yeah, so I think it's actually quite exciting. So there's data and there's architecture. Let me talk about maybe architectures first. So for a very surprising, for whatever reason, we've been using transformers for the last 7 years, and it seems like people have not been able to really substantially move the needle with different architectures. So I know
Sorry, Percy, while you are muted, I was trying to go through some questions.
Okay, can you hear me now?
Yes.
Okay, I don't know why my computer keeps on resetting, but where was I? So I was talking about architectures. So we've been using transformers productively for a while, but they have critical limitations. Like if you want to extend the context length to 1 million, now the cost of that is 1 million squared if you do it naively. So some of my colleagues here, like Chris Ray and his students, Tree and Albert and others, have been developing these so-called state space models that are alternative to transformers. And that is a promising way of looking at how you can circumvent some of the limitations of transformers. Of course, there's so much, whenever you have a technology that is been around for a while, things are kind of optimized and tailored for the transformer. So it takes a while for new ideas to really bear fruit. On the data side, I think this is actually really, really important work that often in machine learning, I feel like is really underserved. Because everyone wants to develop new fancy algorithms and models, but the data is really, really important. And actually, one of my colleagues, Ludwig Schmidt, who is starting at Stanford, has this work on data-centric language modeling, where the goal is to develop data sets such that if you train a model, you get the best results. So hopefully these type of initiatives will encourage people to spend more time thinking about how to filter and process data. And we've also been doing some work on figuring out how to select data. So when people say language models are trained on the internet, that's kind of a lie. I mean, it's a subset of the internet, and it's carefully curated and filtered, but it's certainly not the internet. If you go look at an internet dump, you'll be appalled by how bad it is. And we've been developing, techniques based on importance reweighting or distributional robust optimization to try to automatically select and weight the data points. So there's a lot more to do and discuss here. But I hope that more data-centric work will become popular because we really need a lot of it.
It sounds like context is an issue. Yeah, sorry, Percy, I was trying to summarize. So context constraints because of the transformer limitations mean that there will be potentially new models which are some of your colleagues are working on in other places that can increase the context capabilities, and data-centric approach can also give another boost. There is a question from the audience about music. It's an interesting question. I don't know if you've seen, maybe you haven't seen work on music. Has that been entered in a model? Have you seen some work on foundation models around music?
Yeah, that's actually really interesting because we actually have built foundation models for music. So one of my postdocs, John Thixton, who's going to start at Cornell, has been working on foundation models for music. And it's the idea, the challenge there with music is that it's not a linear sequence. There's multiple tracks, and how do you model the time series, and how do you deal with long context? Again, long context is a big issue. And also, going back to the point about language models and language being sort of a meta, this idea that you can express natural language instructions in language. And with music, how do you use a music model? You can put some language, but the data situation for music is also a lot less well developed. And the copyright concerns around music are very, very formidable compared to text or images.
Fundamental problem that we discussed earlier before, much like the next token prediction for language worked, but here it's unclear what's the unit kind of problem, correct?
Yeah. The data, it comes back to data. If you have the right data and you can use it without copyright issues, then I think you're good to go.
There are some questions about whether countries should, so I'm just saying one more, countries should have their own country-specific LLM. I think we kind of cover that one has to customize this for their own values and context. I'm not sure we have to add something on that.
Short answer is yes.
Short is yes, exactly. And maybe there is, just because as we have 1 more minute, have one last question for you. And I'm sure the audience will be interested in this question also. We talked about the AI researcher potentially. Today is a copilot, but it's getting there slowly. But eventually, research is about understanding reality, understanding ourselves. You talk about the values also, which are ourselves. Will AI help us understand reality better? What is your take?
I hope so. I think so. And I think that, to put a little bit of a spin on this, already, at least my perspective on ourselves has changed in the sense that people talk about language models in a little bit of a pejorative way, like, oh, they're just predicting the next token. But the fact that they can go so far also makes me realize that, well, actually humans, aren't we a lot of times kind of going on autopilot and predicting the next term? And how often are people hallucinating and making things up? So it, I think, puts things in perspective a little bit. And I think that language models can, this goes back to an earlier point about how these are in some ways easier to evaluate, but also to control than humans. I think we can make them better in ways that we can't really do with humans. And we can make them more attentive to the concerns of how do you ground yourself in reality. And especially if you move away from this very narrow view of language models just generating text, but really the foundation model idea of how you can take a huge amount of data, extract insights from it, use it to drive decisions. That, I think, is a really just generally powerful concept that hopefully will get us closer to some of these more ambitious goals.
Thanks, Percy. I love the idea that we can do a lot more with models than we can do with humans. Naturally, we can experiment with them, poke them, change them, scale them, do whatever. So given their capabilities, it sounds like we may have lots of space to improve things and get them to understand ourselves better, our values better, our world better, become scientists helping us. And who knows what's next. But obviously, we're in a fascinating journey. You are in the middle of it. Thank you for taking the time to share some thoughts on the many important questions. It's always a pleasure. So, Percy, good luck going on with the amazing project you are on. We are all thankful to the work you are doing, obviously. And thanks for your time.
Thank you, Theos, for the great conversation.
Thank you, everybody.